Hello, everyone, and welcome to another episode of Philosophical Friday. These are your co-hosts, Peter Birmingham, and yours truly, Duncan Palamurdas. And today, we're also joined by Ben Kushigian, who is a PhD student at the University of Washington studying computer science, and started playing poker at the start of the pandemic and is currently interested in using and improving existing technology, for example, solvers and hand databases, to make learning poker easier. He's also an invaluable and highly articulate member of the community with a lot of great insights, both within the world of computer science, but also on other areas as well, like music, as you can see from Ben's background. Gentlemen, how are you today?
I'm doing great.
Excellent, excellent, very good. Peter, how about yourself? How are you doing today?
Oh, I'm doing very well as always, Duncan. Happy to be here. And in case our listeners may have noticed, it's been made official by today's intro. The big boss man is out and I'm in. So it's Peter and Duncan now. We got introduced properly. So yeah, we're very happy about that one.
Nice.
That's exactly right. And
moving on up.
Indeed. So Ben, let me ask you a question so we can start things off. Why does technology in general excite you, and what are some things that you are interested in the current setting of poker technology, and what are some things that you would like to see in the future?
Technology, it makes life easier in theory. And I mean, I guess I'm more interested in solving problems, and like technology is where I solve problems. Yeah, I don't know exactly why. I think I like the process of coding and solving problems and figuring out, like, I really like coming across a chewy problem and trying to find new ways of looking at it. And ever since I started programming, so I was not originally a mather or a programmer. I got into this in my mid-20s. And I remember very early on, whenever I had a thing I was working on, I'd try to write a program to solve it.
Mm-hmm.
And I end up spending more time automating things that I don't do that often that I do actually like doing. But that entire process of seeing like, oh, there's a pain point, like maybe I can automate this, is a very fulfilling feeling. And so coming to poker and seeing a lot of things that I feel like could be done, yeah, for lack of a better word, better. Like I think there's a lot of things that could be improved upon, a lot of workflows, and in part seeing all of the cool things that people have already done. Like solvers are really cool.
Mm-hmm.
Like every time I open up something like Pio Solver or GTO Plus, I'm blown away by how much work has gone into these tools. And it's the fact that they're so good that I'm like able to see that things that could make them better. Like, oh, this is so good. Wouldn't it be awesome if it could also do this? And yeah, I guess it's just it's a medium for like creative juices to flow. And I think I just enjoy being creative.
Absolutely, and it opens the question of what are some things that you would like to see automated? What are some things you would like to see implemented in technology that currently we're not having?
Well, there's a lot of things, and I kind of want to open technology up even more than just solvers. Like here's one thing that I would like on a HUD, right?
Mm-hmm.
Currently we have colors,
right?
And these are like bins. Like you are green, which for me means like passive, like if you're limping a lot pre-flop, and if you're, I have certain exploits I do against green players, and I have certain exploits I do against red players.
Mm-hmm.
And this is, I mean, I think this is very useful, but like sometimes I want to say like, oh, this player does this thing that's kind of green, but this thing that's kind of red. And like it would be great if I could just have like check marks, right? Like this player, bluffs too much on the river, but calls too much, stuff like that. So this is not like a super crazy technological thing. It's like a user interface kind of thing, right? So there's a lot of like human facing things that I think we could improve. Data visualization is another one. One thing that I found in solvers, we have a lot of tooling for understanding what a strategy looks like in a vertical sense. Like this is what I'm doing in this spot. Like I'm using a large sizing, I'm polarizing with this part of my range, I'm, block betting with this part of my range. But what happens is what happens to my different lines? I don't have a good way of visualizing horizontally, like over time as the hand plays out. And this is a much harder problem because you have to take into account different turns, different rivers, different actions. But a huge thing that we're not seeing in a solver is different composition of your lines. It's easy to approximate a spot and it looks almost right, but if you were to approximate each consecutive spot, you're horribly imbalanced by the river because you were 5% off here, 5% off there.
Right.
And if you're not thinking about your range composition with all of these lines, so tooling to help that. And again, this is nothing technologically like innovative. This is just human facing stuff. So that's half of it, right? Like, how can we take the information that we already have and present it better? And then the other half is, how can we, right now we're asking one question was, what is equilibrium? Or if you know locking, like, what's the max exploit? But is that really the thing that we want to ask, right? Do I want to have the most complicated solution that gets the extra 0.001 big blinds on the river? Or do I want to have a program that tells me, hey, this is a thing that, okay, I might be losing a little bit against a solver, right? Maybe I'm losing like 1% of the pot or 2% of the pot. But this is a thing that you can sit down in an afternoon and understand. And maybe even something that generalizes. Here's a bunch of boards that, like, here's a strategy that basically applies to all these boards that you can learn in an afternoon. And now every time you see this spot, rather than having to spend the 3 or 4 days going through and like collecting data, this is it. Like, this is a simplified thing. And yeah, like that is now starting to become a technological thing, because we are no longer like this is like a theory thing, almost like a game theory thing. We're having this trade-off between complexity and simplicity. And where is, we have a dial, right? We have a dial, and where along that curve are we going to be?
This is very interesting that you mentioned that, because you make at least 2 interesting points here. So the first one is you're talking about user interface, right? I mean, and the thing about user interface, anybody any engineer out there who's listening to us, they will know that this is the #1 thing that they're trying to always improve, right? Whether you work over at Google and its presentation of how to do your search engine, or a video game, or on Twitter, whatever it is that you're doing, user interface is very, very important. And you're absolutely correct, whether it's color coding or some other way to make it more accessible. And the second thing, which is incredibly interesting, you are illustrating a very important dichotomy when it comes to technology. And that dichotomy is the one between correctness and ease of use, right? So on the one hand, we want to be accurate. We want the answers to be correct. But on the other hand, we want the answers to be human-like. We need to be able to follow them, right? And you are actually really pinpointing a very soft spot, or a very weak spot, if you will, that has been generated from GTO-related strategies, right? Because they are notoriously inhuman, right? They're notoriously computer-like. So they're really far away from what a human can actually memorize or sit down and use. And is that, first of all, is that fair? Like, again?
Yeah, no, that's a great summary.
Oh, good. And the reason why I'm having that introduction is because I would like to parse this into, a few different steps. Like, for example, you mentioned HUDs. I definitely want to go back to HUDs, and we're going to talk about them. I mean, we had a lot of questions about HUDs. We can talk a little bit about that. But before we go there, what would you say are some issues with whether it's GTO related AI or AI in general? Like, what are some issues? And to give you an idea of what I'm thinking about issues, like things like you and I, outside of the podcast, we've talked about the issue, for example, of overfitting, or we've talked about an idea in the past, not recently, what I would call instability, like a sensitivity to initial conditions.
Yeah.
Do you want to maybe tell us what some of these problems are, or you can tell us what are some other problems that happen with AI? Maybe you can give a little bit of a definition for the listener.
Yeah, well, I like to think of it in terms of pain points, because at
Mhm.
the end of the day, I'm a newish poker player. I've studied a fair amount of theory. I still probably have under 200,000 hands under my belt, maybe 100 to 150. I'm
Mhm.
still learning. I don't have a cohesive strategy, right? Like, I am a part-time poker player. I'm in grad school. I have a whole bunch of hobbies. This is a thing that I can, if I'm lucky, dedicate 10 hours a week to, right? On
Mhm.
average. More on breaks, less during paper deadlines. And how can I get technology in such a way that I can first that I can afford it, right?
Mhm.
And like something like GTO Plus is very affordable. Pio is a lot more powerful. It's also a lot more expensive. And I actually kind of want to get into, the cost of entry into poker in a second as kind of just like a fairness issue.
Mhm.
But yeah, we can push that on the stack. But so yeah, so that's the first pain point. Is just like, can I use technology without having to invest a huge amount of time to be able to get something useful back, and in particular with solvers. And the second is just, I mean, I guess it kind of ties into the first, but like, I can eventually answer questions that I want,
Mhm.
but I have to do a lot of digging. Like, I'm not the first to make this analogy, but like solvers are basically we are scientists inside of a lab, and we are running experiments. We're saying, if we do this, if we give this range, if we give this bet size, this happens. If we node lock here, what happens? We can even make predictions. We can make hypotheses, and we can take these things down, make notes and stuff like that. And it would be great to have an easier turnaround and kind of, yeah, constrain the search space. Part of it comes down to like instability, like what you're talking about. Is it's very easy to there's certain spots where there's just two totally different looking strategies that are just based on minutia. Like, you could even have identical inputs but slightly different algorithms, and they will find very different
Right.
looking equilibria. And this is I don't want to say it's a problem per se, because this is just how things look, but like, is there, yeah, how can we get like, in software engineering, right? Like, it's very important that we have predictable results. Like, I've come up with a few ideas that I've pitched to my advisor and my co-advisor, and one of the things they've pushed back on some of these is, oh, that's a really good idea, we've thought of this before, and the problem is that you're suggesting a system that's going to act differently, and so you can't really rely on the results to be able to build off of them in the future, because they might change. And as somebody that's trying to like, oh, I thought I understood this spot, and now I'm looking at the solver and it's totally different, like, you're kind of gaslighting yourself, right? And that adds friction in your internal mental model. And on the other side of that, maybe you have a better understanding of what the landscape looks like, but unless you're really trying to say, like, I want to understand this for the internal benefit of understanding this. Like, if I'm just a poker nerd and I just love learning about poker and I'm not trying to implement it, that can be great. But if I want to have a way that I can quickly improve my game, that's a problem, and that's extra friction in the system that I don't know if I can get rid of that. I mean, that's just kind of part of the complexity, but these are the kind of problems that I think confront users of solvers and tech in general.
Absolutely. And it goes back to the interface that you were talking about earlier, right? I mean, it could be an inherent property of the game, whether we're talking about instability or you said different algorithms yielding different results. But in the end of the day, when the question is, what should I do in that spot? If the user is getting contradicting answers and they don't necessarily have the technical know-how of how they got there, exactly the same way, for example, that an iPhone user has no idea what's happening in that little thing that they're holding in their hands. They're just clicking buttons and hopefully they get answers. That could potentially be a problem in that sense, right? And you're making a very good point here that the form of instability, actually instability is unstable solutions is actually a technical term that comes from differential equations. But in any case, the instability comes into different shapes. Sometimes you have different slightly different initial conditions and you get totally different results, or sometimes you have the same initial conditions, and because you have a different algorithm, namely a process by which to work these things through, you also get different results. And I mean, nerds like us, we love that stuff, but the thing is, when it comes to the user, it can be a nightmare, and it's a question of, is that thing even working, right?
Yeah, I've seen questions on GTO Wizard, who I want to mention just because I think they're doing great work. I've seen questions in the GTO Wizard where folks are saying, hey, I ran this exact same everything in Pio, and I got a different output, and is there a bug in Pio? Is there a bug in your software? And like, what I think it's helpful, maybe we can chat about this a little bit, but like to help realize that solvers are a search algorithm, and you can search, you can take different paths and approach the same point from different directions. But if you're coming from different directions, it might look different, right? Even though you're very close to the same spot. And without understanding the implementation details, like the user should not have to know the implement. At some point you will need to, but like up to a certain point, like the user should not need to know how we're implementing this. And if they have to, I feel like, and I don't know, again, there are certain things that we're just not going to be able to fix, but like this is kind of like the type of confusion that users might come across.
Absolutely. And the way these problems are being solved, inherently, they have some difficulties and complexities that the creator, the programmer, needs to actually understand, right? I mean, we need to understand exactly to what degree the solutions that we're suggesting are imperfect, and they are imperfect, right? To lesser or greater extents.
Yes, that's another really good point, is that we are already working. I think you put it great on Andrew's podcast. You said we're solving an abstraction of an abstraction of an abstract. I can't even say it, but an abstraction of an abstraction of an abstraction. We are solving a very imperfect form of this. And so we're already getting questions of construct validity. We're already getting questions of, is this the right? And then once there's like, there are questions. This is kind of similar to like cursive dimensionality, where like once you start getting like really big search spaces, it turns out that like everything's kind of close together. Like there's a lot more different looking things that are very close together. So in kind of I think you would take you wouldn't agree with this exact definition of how I'm using it, but like I kind of think of like, if you have a bunch of different bet sizes in your strategy, like if you have a very dense game tree, I'm thinking that is like a lot of different dimensions,
right?
That you can like move around in. How much am I betting, 22% versus 24% versus 26%? You can think of this as like this really like, n-dimensional space, and your strategy is just a point in there. And so as you get, better solves, there's actually going to be a lot more noise in which, where you are approaching this, equilibrium point from, let alone that there might just be like 17 different equilibria.
Absolutely. Ben, if you don't mind, let me just take one step back for the listener, because again, dimensions is sometimes, people are using it in physics, and we're talking about the 2 dimensions, the 3 dimensions. What? There is more than 3 dimensions. We can think about 4 dimensions, and then all the things go a little bit crazy. So this ties really well to the idea known as overfitting, right? And it's another issue that shows up with dimensionality. Sometimes more is less is essentially what you're trying to say, right? I mean, giving freedom, extra freedom to the algorithm can be problematic, because then the algorithm starts too much noise. Do you want to talk a little bit about overfitting? And I also have a metaphor I can give after that. Like, what is overfitting, and why is it an issue in the current technology, would you say, in your own words?
Why don't we do this? I will give my example or my explanation of overfitting, and then you will give them. I think you're a lot better at like distilling these things down, but I will try my best here. But to the listener, if I make no sense, don't worry, Duncan's going to save the day in a second.
I don't know about that. We'll try.
So overfitting comes up a lot in machine learning, and in machine learning, what we're trying to do is we have a bunch of data, and there's some signal in the data that we'd like to capture, and then there's some noise, and what we're doing, we have basically different, you can think of them as, I guess, like, let's just think of them as equations that can like try to say, like, we're trying to find an equation that takes some inputs and then gives an output, and that output is supposed to kind of correspond to reality in some way. Now, you'd think that you'd want a really powerful equation that can get all of the nuances of your data, right? You'd want to be able to, if there's a little blip over here or a little dot over there, you'd want to be able to capture that. But what happens is, if your equations, if the models that you're using are able to capture too much of this low-level detail, you're going to start capturing the noise that we don't care about. And so it's kind of this wild thing in machine learning and in like all of these correlational modeling type things that we have, all sorts of like statistical modeling, that by constraining the strength of your models, if you say, hey, I'm not letting my model have the full power, I'm actually like tying one arm behind its back, then that gives better, more useful information because you're not capturing all of just the randomness that's inherent in every data set.
Oh, this is a beautiful technical explanation, I would say, and I really like the idea of using the word blip, right? And because essentially what you're talking about right now is a distinction between intelligence and wisdom, right? So the machine that can actually captures the blip is incredibly intelligent, but it's not wise.
Right.
So essentially what happens with overfitting is extreme intelligence with no wisdom. And the metaphor that I like to give is that imagine that you have a person who's naive, and they want to learn how to dance. So in order to learn, let's say that to simplify the example, they want to learn a spin. So we present that person who's naive, but actually very good at imitating what they see. So incredibly kinesthetically intelligent, but perhaps a little bit naive. Yeah. And they view a bunch of dancers in succession, they do the spin, then the second dancer does the spin, the third dancer does the spin. And then remember, our person who's trying to learn is watching at all of these dancers as they spin. And one of the dancers trips and falls down, right? Right. So, and then the next dancer goes, okay, maybe another dancer messes the move up. So our naive person who's trying to emulate all of those dancers, they will also try to emulate the fall. They will try to emulate the, I tripped. That must be part of the sequence, right? That's why I'm calling them a naive dancer, because they don't understand that that's noise, right? So one of the dancers fell. So our friend is trying to capture that, and that's exactly the blip that Ben is talking about, right? So sometimes we have to restrict the algorithm and tell them, no. If something moves too much, just ignore it. You have to. So, and like by restricting the algorithm, we actually are able to avoid, falling for the noise, so to speak. And unfortunately, when it comes to GTO, there is a lot of noise. The problem is so complex that we have this inherent problem between, okay, we need to let the AI capture all of that minutia, exactly like Ben described earlier, but at the same time, without capturing the noise. And one way we can fail to do that is if we allow, for example, the solver to have all sorts of different sizings, right? We're talking about like 13,000 different sizings, like with decimal points and things like that. That would be potentially a problem, which is, by the way, why we're restricting the sizings. Peter, do you have anything here about the issues with AI? Anything you want to ask Ben on that?
Yeah, I think like it's funny, like always when it comes to solvers, I think, and this is especially coming from somewhat of a layperson who, really doesn't have a great understanding of coding and, the programming sides of things. Like, the first question I think most sort of people will ask when they come to a solver and they get the output and they see all the strategies and, what's lacking here? What the biggest lack, especially from a beginner perspective, is an explanation of why. Yes. And that is the that's the key piece. So from a programming perspective, how difficult is it to get, I'm now personally, even as somebody who doesn't understand this, I'm assuming this is probably quite a mammoth piece of programming to try and get the algorithm to translate itself into something we could understand.
I mean, before you could even get into the programming, philosophically, how difficult is this to understand? This is a great question, and it's something that I've started to think about. The problem is that the way we think about the world, we want an explanation, and what an explanation is some sort of mapping of abstractions that we can understand, thoughts, concepts like a flush draw, value bet, merge bet, range check, all of these different things, block bet. These have some internal semantic meaning to us, but to the solver, these don't exist. These are mathematical equations. These are just, this is the thing that's a highest EV. And trying to find a good set of abstractions that map not just to 100 big blind poker when I'm, in a, RFI pot, where the, button opens, big blind defends, right? This needs to map to 5 big blind poker. This needs to map to antes with ICM consider, all of these different things, right? We need to find some set of abstractions or some schema of abstractions. When I say schema, I mean, basically a way of getting a set of abstractions by saying, oh, in this spot, we have these sets of abstractions. In this spot, we have these sets of abstractions. They're basically an abstraction of abstractions. But yeah, we need to find some sort of way that's flexible enough to fit to all sorts of different positions. And then we need to start building up in terms of motivations. Why is this happening? Well, at the end of the day, it's because there's more value in doing this than something else, or it's preventing, our opponent from doing something. So how can we do this? Well, there's kind of 2 basic ways, and then maybe a third hybrid approach. The first basic way is saying, okay, let's map our abstractions. Let's say we have our own, we're humans, we know what we understand. So let's take those and try to apply those to solves in a way that makes sense. And you can see this already a lot in current like if you look at like range constructions, you can like you can say like, oh, what's the range construction of my turn barrel overbet? Oh, I'm doing a lot of flush draws, a lot of top pair good kicker, a lot of sets, 2 pairs, etc. And that's still not answering why, but we can maybe start to then look at the response to those things. And by digging through how different responses happen and then node locking and resolving, like, right, there's all these counterfactuals. Like at the end of the day, the why is like, well, basically like, why would I not do this? Okay, that explains why I do this, because everything else is bad in some way. And the other way would be some sort of automatic approach where we find patterns again by looking maybe at counterfactuals or looking at different responses, and then automatically generating a set of abstractions that say, oh, the reason I'm betting here with my flush draws is because I value fold equity, or the reason I'm checking my flush draws is because they have a lot of nutted hands that they can check raise me with, and I don't want to get like check raised off my equity, so yeah, automatically finding these abstractions that we can understand and then figuring out, there's kind of like this chain of like what's happening and then like how do I map that in a way that a human can understand. And this kind of starts getting to some of the stuff that Duncan and I have been chatting about. Unfortunately, I will be hinting a little bit at some ideas that I don't really want to talk about in public yet, just because I don't have time to work on them just yet, but I'm very excited about them. And yeah, at the end of the day, I want somebody to do them. I'd love it if it was me, but if if in like 6 months I still don't have time to work on this, I might just like go and talk about it on air. But yeah, I think that there are some tools in machine learning and unsupervised learning. They've already been applied in like Hold'em Resource Calculator, HRC. They do this preflop with they use a clustering algorithm to find hands that are very similar. And so I have some ideas that can use this sort of automated procedure, or maybe a hybrid approach where humans have some sort of input, and we can start discovering patterns that map nicely to a high level for the math people. I'm almost thinking of like a homomorphism from like our from this high, this structure preserving map where it's like I have this high level structure, then I map it into this much more complicated thing. But all of the under the, most of it's like an approximate homomorphism. Most of the structure is preserved when I map my high level idea down to a low level.
Absolutely, and to add to your great intuition there, as to why, essentially it can be distilled to the following property. Proper machine learning never tells the algorithm what they should do, right? I mean, the example is if you try to teach a kid how to play chess versus to teach a machine how to play chess, the two approaches are completely different. With a kid, you give them rules, like you say, for example, things like, try to control the center, and the poker equivalent would be try to fold bad hands, raise with good hands. But this is not how you teach a machine how to play poker. You never tell the machine, go ahead and fold this hand. What you teach the machine is what you teach it a value system, right? Then you let the machine decide which hands should be folded and which hands should be played based on that value system. So it's always about a value system for the machine. And to some extent, you can do that to the 5-year-old. You can give it a value system. You can say, hey, the goal is to make money here. However, it's too complicated to go from the value system to an actual strategy. So sometimes you just have to help the 5-year-old with like some hints, maybe fold your 7 deuce offsuit, maybe raise with your aces, right? Nudge it in a certain direction. But if we ever nudge a solver in any direction, we've already failed. We're not doing machine learning, right? I mean, we're doing memorizing at that point, which is
and I mean, this kind of gets into like node locking. You can think of a node lock as a nudge,
right?
And maybe you want to, like, maybe there's actually a lot of use, I think, and I don't know how to implement this, but like of saying like, hey, I want a strategy where I just do this thing. Like, find me the best strategy where I know this simplification, like, maybe optimally, like we never do this, but I'm like, hey, in my game, I think this is actually a pretty good move. Now find me I'm making the solver always shove 10s on this board, right? Find me a strategy where this is actually like, this is defensible and like nobody can really exploit this very well. But yeah, that's starting to get into like very exploitative stuff, which can be good in certain situations. But yeah, like, yes, we want to, in general, let the solver discover the things it wants, but we can constrain where the solver can look at, like how many things it can look at.
Absolutely. And I would argue that this is actually falls into, the value system that we're talking about, right? I mean, we're essentially changing the rules of the game. We say, listen, I want to solve a game where, shoving there is part of the moves. Shoving with 10s there is part of the moves. And then from there, the value system remains intact. Here's the value system. Tell me, what's the best,
Yeah. Maybe this would be, I mean, so we're kind of talking about it. I feel like I don't know what people know about solvers and the algorithm behind it, but we're talking about value systems, and that's basically what solvers do. Is there's this algorithm called counterfactual regret. It belongs to a domain called machine learning. And have you read the original CFR paper?
No, I haven't actually.
I started to, and it's dense. There's a lot of there's a lot of equations that are tough to get through. I have an undergrad math, so I'm not like afraid of equations, but like they're usually I think one of the things that people don't understand when you're reading a math paper is that, like, if you're experienced with this, you're actually speaking another language that, as I said before, like, I see an equation and I have some semantic meaning to that. I see the summation and I'm just like, oh, like we're just taking this average of things. And but like sometimes you see an equation and you're like, I have no idea what each one of these terms are doing. You're multiplying these 5 terms and I have no idea what each one of these things are doing. And there's a couple of those in there, and I ran into it, but I can understand it at a high level. And basically the idea, counterfactual regret. So we build a game tree, right? And we start at the root, which is like, maybe it's the flop, maybe it's pre-flop, maybe it's even the river. And you have a game tree, which is just the nodes are current positions. And then each branch of the tree is a different action that someone can take. And you get to the, you eventually get to the leaves, right? You go through this entire tree and you get to the leaves and you say, oh, how much is player A winning here and how much is player B winning? And you propagate that back, all of this information. But what you're also propagating back along the tree is how much another hand would have made if it was there. So let's say I shoved tens on the flop and everybody folded. But if I check raised tens, then got to the river, like I would have made twice as much money. Well, I should now, instead of shoving tens, I should move it over. I have this regret back at this point where I diverted my tens to another place. I'm like, damn it. Why did I shove tens? Everybody folded. And I think everyone's, they get the nuts and they go all in and everyone folds. You're like, shit, I should have done something else. Right. I should have slow played it or something, right? That is basically what the algorithm is doing. It's saying you come back to the node where you messed up and you're saying, okay, let's do it right. And you just iteratively do this over and over and over again. And it's this really, and so what the counterfactual regret paper is saying is that basically this is how do I say this right? It's basically a way they have a proof that this eventually goes to zero. The regret eventually, that's always going down or almost always going down. And what's more, there were other techniques that did this before. There was regret minimization, but it took a lot longer. And this counterfactual regret it's a kind of a loosening of the problem, but in a nice way that you get much faster convergence to zero regret. And so that's basically what counterfactual regret is. It's just this iterative process where two agents are always trying to minimize the amount of regret that they have. And, coming from going back to value systems, that's kind of what we're doing is we're setting up this system where we have these two different agents that are trying to explore the world, and we give them this notion of regret. And this is what they value. They regret that they didn't make more money. And so to your point, like how can we mess with this? Well, maybe we can start tweaking that value system, right? So one idea that I had that I think is probably, I think there's maybe a 20% chance that that 20% might be high. There's a small chance that it will work. There's a big chance that it'll just blow up, but I'm very excited about it. I think it's really cool. So maybe we can encode into the value system some sort of benefit for having a simple strategy, right? Not only are we encoding how much money we win, but how simple was our strategy to get there? One way to think about why this makes sense is that by the time I get to the river, if I have a very complicated strategy, I will probably have messed up. And so I will be losing some money at that node. So the more complicated my strategy was getting there, the more tax I should pay for human error. Now, this does a couple of things. First and foremost, it makes our search space what I'm going to call non-convex. Now, convex in math just means that from any point, I can see any other point, right? If I'm standing in a spot and you're standing in a spot and we're in a convex space, we can always see each other. And the reason that's good for optimization problems is I can always see where the best point is. And so I can always move towards it. There's not like some divot cut out like a wall that I run into when I'm trying to optimize. So if I'm trying to find an optimal solution, I can always get there.
Right.
Now,
a donut would be an example of something that is actually not convex in 3D.
Yes.
Right.
Yeah. If we're standing on opposite sides of the donut and we're trying to find each other, like, we never going to do it.
It's going to be hard. Exactly.
Yeah. But a donut hole is convex.
When a donut hole is convex. Exactly. So we want to be in the donut hole.
We want to be in the donut hole. And I'm a donut hole guy. Yeah.
And just to summarize some of these things for the listener, because I know it can get quite difficult. So the idea of the counterfactual measurement that Ben is describing here is essentially what mathematicians will call essentially in some sense an error function. But the way we want to think about it is as a value system. And what essentially telling the algorithm is, before anything else, we tell them, listen, if the discrepancies that Ben just described are big, you should be sad. So we're essentially instilling a value system to the algorithm. So the algorithm does not want to see much change between what happened and what could have happened had they repeat this experiment again. And that's one thing. Now, math, on the other hand, comes to the rescue. You notice here Ben also mentioning that it's not enough to say, oh, I want to minimize the regret. We have to actually show mathematically that regret theoretically could go to zero. That is, we can choose a strategy which, if we actually did it again, that strategy wouldn't improve, right? You saw Ben mentioning that earlier, the idea that not only we can reduce our regret, but that regret essentially could go to zero practically, right? So there is a point of optimization, right? There is an optimal point, and that's actually not easy to do mathematically, to show that this can be done. And to the third point that Ben mentioned so eloquently there, the idea of we gotta make sure that the things that we're doing are not complex. So we're instilling, and this is essentially Ben's idea, and hopefully I really want to see you implementing one day. That would be incredible. We're instilling a new value system to the algorithm, and we say, okay, I no longer care just about the right answer, but I will also care to get to the right answer simply. So every time you take an extra action to get me to the right answer, I'm going to penalize you. So you will get penalized both for getting the wrong answer and for getting a complicated answer, right? So it's essentially a double instilling of a value system. Now, of course, that's easier said than done. And when you do that, sometimes in a similar idea in mathematics, some of you mathematically inclined, the idea of bias and variance trade-off, right? So sometimes there is a trade-off between getting something that is accurate and get something that has a little noise. We can't get both at once sometimes. But that would be great if we could find, actually, I'm getting all excited talking about it, if we can find a value system where we're penalizing the solver for giving us a complex answer, that would be incredible. And I mean, since there are already software that calculate the GTO solution, we already have a measurement of how far off we are from GTO. So we can, the algorithm can tell the user, listen, this is how much EV you're sacrificing here to get that simplified solution where you can, let's say, bet 100% of your range there instead of having to do this pesky randomizer, or you can cut the bottom of your range, or you can add a little bit extra, or whatever it is. So it is essentially an addition of an extra value system. Would you say that's fair?
Yeah. That's that is another nice thing, that like we have a good benchmark that we can work against. And it's ultimately a trade-off, right? These are the hardest problems, right? If I can make more money and work less, that's a very easy job offer to take, right? But like, if I have to work less, I work 10 hours less, but I'm also making 25% less money, like, is that worth it? This is a time versus money trade-off, and these are all of the interesting questions. And this is kind of like what we're coming up against, right? We have these optimal solutions. We're probably not going to get them a lot faster. We're probably not going to get a lot more accuracy. We're making marginal improvements, and that's great. But now we need to start thinking about, okay, what's the trade-off between my effort and my value gain, right? And yeah, these are just inherently, I like to say that like math can only solve easy problems, right? All of the hardest problems out there, math, like, okay, and I say easy with like, okay, gravity is easy, right? Not like not Einstein relativity gravity, but like Newtonian gravity is easy. I mean, it took us thousands of years to figure out,
Right.
but like if you look at the solution, okay, that's very nice and elegant. But then you come across a 3-body problem, right? And we're already getting to a point where it's like, you know, how do I talk about the interaction of, you know, I can talk about 2 bodies, like a moon around an Earth, and okay, but 3 bodies is already getting so difficult that I need to stretch the limits of, you know, what mathematics were at the time. And now talking about like, you know, can I solve analytically like you know, an entire solar system? Actually, I don't know if this has been done. I'm assuming it's computational methods. I'm assuming that this is mainly being done with numerics, and that we don't have a nice analytical, like closed form solution to it. Yeah,
it gets complex very quickly. You're
yes,
absolutely correct.
Yeah. And so let alone something like neuroscience or psychology, right? Like these things are way more complicated than I don't know, differential topology, right? Like these are even though one seems way cooler and harder, it's actually trying to understand like how a society works, right? How all of these individual people work is it's much fuzzier. And we're kind of getting to the point where we're no longer like when we start trying to understand a strategy in a way that is useful to people and that like can work in complex dynamics, like how do I think about my strategy in an easy way that can adapt to this play style or that play style. We're quickly getting to the point where it's so complex that having a nice closed form analytic solution, or like, I mean, even an equilibrium isn't really a, you know, the way we're approximating it isn't really like a closed form solution, but like these rigorous methods that like a Nash equilibrium, right? Like we have this nice clean definition, but we're quickly going to run into issues where it's just not the right thing for the job. Like and that's more and more. I was a pure mather when I was doing my undergrad. I loved like the algebra, topology, you know, complex analysis. Like these are beautiful. But more and more, I wish I'd done more statistics. I wish I'd done more like dynamical systems, you know, yeah, differential equations. These like more real analysis type stuff. Like these are the things that I think are, you know, trying to map reality to a mathematical model. Like that is, it's really hard and it's really cool. And
right, yeah. It gets dirty. Now the thing about, you know, some of these pure mathematical subjects that you're talking about, like topology, is that they're abstractified to the point that they're so clean, and because they're so clean, they have precise answers, right?
Yeah,
but when we get to the real world, things are very dirty. We don't know what we don't know sometimes. We're not exactly sure which value system we should prioritize over another, and all of a sudden things get really complicated and fuzzy, but at the same time practical, right? Because they're the real things, you know. Sean Carroll has a really nice metaphor. He calls it the spherical cow. It comes from a farmer who goes to a physicist and he says, dear physicist, I have these 20 cows and I want to produce the optimal amount of milk. I want to feed them the optimal amount of grass. He's like, can you help me figure out the problem? And then the physicist is like, okay, let's assume a spherical cow.
Right. Yeah. Assume all cows are spheres. Yes.
Right. to make the problem easy. And that's to your point, right? I mean, it's so confusing otherwise, right? So we do a lot of simplifications in math to get these clean answers, but in actuality, it's getting too complicated.
Yeah.
Speaking of complicated, we have a lot of questions here about
let's dig into them.
Technology and HUDs and things like that. And I want to make sure I give shout out to everybody who asked this question. So Dennis Peterson wanted to know, I'm wondering why are HUDs or heads-up displays deemed as okay to use while playing, but pre-flop charts are looked at as unfair advantage and therefore cheating.
This is a great example of a complicated thing not being able to answer it rigorously, right? This is a societal decision that we made. Like we as a poker community have just through random reasons in our walk through time, right, have decided that HUDs are okay and pre-flop charts are not. Now, I can give certain examples of why they're different. For instance, HUDs are just more information. It's basically helping me remember stuff better about people, whereas pre-flop charts are information about my strategy, right? And those are different, like observations versus, this, ground level strategy. There's nothing that's telling me how to play. Like the fact that I know that you bluff the river too much doesn't actually tell me how to play. There's a lot of deviations that I can make earlier on in the game tree, like slow playing and stuff like that, that will help me exploit that. So actually implementing a strategy versus that information, in my mind, is distinct. But there's not a hard separating line, right? And this is, trying to come up with like a nice, clean, canonical reasoning of why these two things are treated differently. Yeah, this is just, it's the way things evolved. The one other thing I will say though is that there's especially in like, cash games, like I will not be super upset if somebody is like, I don't use pre-flop charts when I'm playing cash or tournaments for that matter, but I wouldn't be super upset if somebody's maybe once you get into these weird 3-bet 4-bet lines, like where like the ranges get fairly narrow, that's when they start mattering more. But if you go into something like tournaments, like the entire like tournament, once you, or especially considering ICM, it's all being done pre-flop. Like a huge part of the game, so much more of the game is being done pre-flop, and there's so many more considerations, right? You're not just remembering 100 different situations, you need to know thousands. And now that starts becoming RTA. So somebody was going to say something.
Absolutely. No. I think this is great, and you're talking about the idea of how great the lines are. There is something reminiscent of a clear line. It's not exactly a clear line, but it is reminiscent of a line. And I would say that charts require no interpretation, while using a HUD is a skill in itself. So HUDs are interpretive, whereas charts are, this is exactly what you should do in that spot. You can actually memorize it. But with a HUD, you actually have to interpret what the numbers that you see mean and how you should react to that. So there is a certain, albeit small, extra element of skill in a HUD. As a matter of fact, if somebody doesn't know how to use the numbers, I would love them to have a HUD in front of them, because they will misinterpret them, right? Whereas with a chart, you can actually protect yourself, especially if you're in a tournament situation, in a push or fold situation. If an amateur has their hands on a chart on a tournament, they can actually limit our edges tremendously.
Yeah. Though I will say that if you're playing like a really strong lineup, a chart gets a lot better. There's like, if I'm again playing cash games, I'm mainly a cash game player. Right. I don't mind if people are using charts, in part because you need to interpret them, but people don't. If I have let's say I have aces and I have a reg to my right, I'm on the button. Let's say that they open to the cutoff, they open to 2.5. I'm on the button, and then I have two fish in the blinds. Well, obviously, I'm always raising, right? But if I want these short stacks to come along and try to get a piece, right, I like, rather than 3-betting aggressively, or my sizes, right? If I'm on the button, I should be 3-betting to like 7.5. But if they're both at like 15 blinds, maybe I should 3-bet a little bit smaller and try to get them to come along. Or, like there's so many different variables that come into play. And it's really easy. Like a chart is just like a snapshot of like this very pristine version of the space. And so if you're not taking into account what the different table dynamics are, what your reads are in different players, your chart is just, you're getting close enough, right? You're not going to be punting. But like, I should not be 3-betting as wide with a short stack, an aggressive short stack to my left, as and so if you're just using 100 big blind charts and or God forbid, if a bunch of people have doubled up at your table and you're playing like 250 blinds deep and you're using 100 big blind, like 3-betting ranges, like good luck. You are losing a lot of value there. So the interpretability definitely comes in with pre-flop charts as well, but I nowhere near as much as to the point of your of interpreting HUDs.
This is actually a very good point, which is, again, back to your point, it's not easy to draw a clear line, right? I mean, things can be very, very, very complicated. Speaking again of no, go ahead, Peter.
Sorry, I was just going to say, Duncan, like I'm a bit probably a little bit more polar on this particular subject. I like, yes, there is some interpretation that go into charts, but at the end of the day, pre-flop is still a strategy. at the end of the day. It's your first point of strategy. And if you have mapped out that strategy, yes, there will be nuance, as you said, Ben, there's going to be certain nuances, and there are going to be spots that require a bit of interpretation. But those spots are probably less often. And I think this is something that came when the recent cheating scandal, when they were talking about people using, RTA and stuff like that, and how the fact that they used it so much online, it almost became like they, to a certain extent, memorized the strategy from the solver. They were using it. They weren't necessarily thinking about it, but that sort of muscle memory kicked in. So if you've got a player who was formerly, say, a losing player, and all of a sudden now they have the first part of the game tree completely mapped out, yes, they will make mistakes, but now their mistakes are far fewer than before. Like somebody, and I'm pretty sure it was Patrick Howard, tweeted a few months ago that if recreationals ever discovered how to play preflop properly, we may all go home. Because the money online now, particularly online, I think live is a completely different animal, but online especially, because that's where the biggest edge comes from, is their lack of a pre-flop strategy, which inherently exponentially makes their mistakes bigger as they go forward in the tree.
No, absolutely. And I am definitely not pro using charts. I don't like, and I really like, I say I don't mind. Like I totally understand why people mind, and like you shouldn't. Like it's against the terms of service. As a community, we've agreed that this is bad. And you're right. It's telling you how to play the game. You are having, computer assisting you to play the game. But I just like, personally, it's not a thing that I get super up in arms about. Though one piece of edge that I've, especially since I play on Ignition, so I don't get that many hands against people, but I will have people tagged as a reg because most of the actions you see are pre-flop. And then I'll see them do something post-flop, and I'll be like, oh, you're using charts. You have no idea how this game works, but so I've been treating them like they're a good player because I haven't seen them get to showdown yet. And I see one hand where they get to showdown. I'm like, oh, you're really bad at this game. Like I could have been exploiting the hell out of you this entire time. And now, so there is actually some information hiding too. So not only is like the theoretical edge going away, but like the amount of exploit that I can do in a certain, that ramp up time where I'm starting to learn who my opponent is. They're hiding all of that. That never occurred to me before, but yeah, that's a really good point.
They're hiding the true VPIP, right?
Right. Yeah.
So speaking of cheating, David Underwood wants to know, will cost-effective anti-cheating technology be necessary to sustain the game in the long term? And what does that look like? And I'm assuming they're probably talking about mostly online, but certainly that could apply to live as well. Any thoughts on that?
I mean, this is not where I've spent a lot of time thinking. I know I've listened to Berkey talk about this a fair amount. And a lot of the this is like one of the drums he's beating. I think yes, I think there's, whether or not it's necessary is pretty darn important. I think it's possible that online poker can exist for quite a while without having like really strong institutional like anti-cheating measures. But like, I don't know, what's a while? Like maybe it's like 3 years, maybe it's 5 years. But with things like GTO Wizard that are out, like you can already just get like winning strategies just for $50 a month, $100 a month. You no longer need, like, it's already out there. Some of the, like, one thing that we will never be able to handle, it's going to be much harder to handle, is like if I have a database of solves that I bought that I can like access locally. I just have a server somewhere. I've basically implemented my own GTO Wizard, but that's very expensive, and it's going to be hard to handle something like that. Something like I've heard rumors of sites. Sometimes I'll go to access a GTO Wizard node. It'll be like, oh, you have to wait 20 seconds. Because we don't want you to use this in hand. So that's happening. But I've also heard rumors of sites keeping track of like when each hand was looked up and having communication with different with actual poker sites, not just the trading sites, but the poker sites. They'll have communications with each other to say like, oh, this hand was used here, and they'll be like, oh, this player looked at this node and that's exactly what this board at this time, and they did that again at the, and you'll be very quickly able to see what if somebody's looking stuff up in real time. And I think that's
I've heard the same thing.
Yeah, that is so easy to implement. That's just data. And this is one place where, like a chess engine, I can just run it in my browser. I can clone Stockfish and, git clone github.com/stockfish and then like run, right? And I can just get the right move and nobody can tell. But poker, it's so expensive to get a full game tree. So unless I'm like running solves in real time, which you need a huge supercomputer to do that, or you have like an entire database, which you need a huge supercomputer to do that, it's not really feasible. You have to go through these centralized third parties. And so I think that there are like anti-cheating measures that are going to be pretty easy to put in place that will get rid of most of the easiest cheating. And it won't be perfect, right? But I do think that these behavioral nudges away from, if we don't make it super trivial to do something bad, it's like what's the thing, like when they changed in Britain, when they changed from like that one kind of gas oven to the next kind of gas, right, where you could no longer, like suicide rates went way down because like the ease, like they used to be able to put your head in the oven and like that would asphyxiate you, but when they put like the new they changed the type of gas that no longer killed you, and just because the means of like an easy action that was like spur of the moment like went down, like suicide rates plummeted by like like 70% or something like that. And this is if we make it harder to just do the easiest cheating, like it's not going to be as tempting. So I think that we can hopefully curb a lot of that. The other thing I will say is that a lot of where does our value come from? It's not against reg battling, right? It's against fish. Now, a lot of fish, I don't think are going to be there. There will be some, and this is just totally conjecture, but I think most fish aren't going to be, or recreational players. I shouldn't say fish. We're all fish, right? Everybody, everybody that exists is a fish. But most rec players, I don't think are going to be looking at these solvers. Like this is a very much reggy thing to be doing, like getting a subscription to GTO Wizard or something like that. And most of my value is coming from them. And if I'm paying a little bit extra to people using solvers, like they're getting a small amount of money from me. But if I play right, I'm getting even more money by exploiting recs than they are getting from me. And they're also not going to be getting as much money as they could from rec players if they're only just using these solvers. So I do still think, like in some sense, it might even be better for, like, I'm not actually saying this is quickly turning into more rake is better, which is not what I'm saying, but like, you could imagine a universe if you tweak a couple of dials where actually recs are being exploited less by the people that are using the solvers. And that's actually better for the ecosystem. And again, I'm not saying that's the case, but like, I think it's more complicated, and you need to hit a certain critical mass before it's so unprofitable to be playing. So I think it's going to take more than just like a small percentage of the user base using these tools before it like ruins the game.
Right, and it is indeed a very complicated issue, right? I mean, it's not like we can fix one thing and then all of a sudden everything is perfect, right? I mean, there's a lot of parameters that go into play for sure. So here's the last question for you, right? I mean, it's a little bit more lighthearted. So Rene Coronado wants to know who would win in a ring game, a neural net, equilibrium calculator, or a top pro?
Oh, that's a good question. Oh yeah, I saw that in chat and I was like, oh, that's really hard actually. I have no idea. First, I want to make a shout out to Rene. He recommended a book which I'm going to recommend called The Alignment Problem, which very much ties into what we've been talking about. The alignment problem in AI is I want to align the value system that I'm giving to my AI with the problem that I actually want to solve. It's very easy to make an AI that does something that looks kind of like what I want, but is actually totally different. And if we're not very, very careful about how we are programming these artificial intelligences, we might get just really bad results that aren't immediately like racist algorithms and stuff like that. Right.
Right.
But yeah, anyway, so shout out to Rene for that. So I actually don't know a ton about neural net AIs. This is not a thing that I've looked into yet. So as far as, and when we say a full ring game, I'm assuming we're meeting with other human players.
Yeah, so I mean, yeah, we can. He didn't say full ring game, to be honest. He just said ring game. I mean,
Okay.
we can assume for this
Okay,
one that
but
it's like three-way, let's say.
Yeah, that it's like they're not just battling each other. There's others that they can both exploit. So this is a question about
Sure.
I'm interpreting this as
Sure.
if I was to deploy both of these into the wild, they're at the same table, but they're, you know, at some game that is primarily humans. Who's going to win the most? And there's a couple of different considerations. First, we need to say, like, is my equity calculator, did it already calculate, or is it able to calculate live? And is my equity calculator just can it node lock intelligently? Is it able to make observations? I think, and I'm really not in the neural net deep learning landscape, but I do know that there are online learning algorithms that might be able to make observations, and you can like partially train a network so that you only need a very small number of observations before you can start learning stuff. I don't know if this is possible yet, but in theory, right? We've qualified this this question about 5 times now, but in theory, in this situation that I'm interpreting that Renee is asking about, I think that you could see a neural net outperform an equilibrium calculator just because it's able to handle fuzzy things better. That would be my guess. But if they're going head to head, I have no idea.
It's going to be very close, probably.
Yeah.
I would agree with that. Like in a head to head battle, one of these two probably is going to win. But if there's actually humans in there, I think the top pro is going to make the most money. It's not even close because, you know, he knows when to switch between GTO and
oh, right. That was a top pro. There was a top pro there as well. Right. I forgot. Yeah. I think, if you're playing with other humans, I think the top pro is going to make the most, unless you significantly improve, the algorithms. But if there's just 3 of them, right? If there's just the 3 of them, I think the top row is going to have a real tough time. But maybe not. Multi-way game theory is tough. I'd say the equilibrium calculator is probably not going to do great.
I would agree with that. I think the neural net, depending also on how much preparation it had beforehand, because you can actually put the neural net untrained to start playing there, or you can pre-train it, which is a completely different story. Man, that's some fantastic stuff. So let me ask you this, Ben. So if people want to know more, you know, they want to reach out to you, like have a conversation, you know, discuss about where can they find you?
Well, I'm on Twitter at, I don't even know my Twitter handle, Ben Kushigian, at Ben_Kushigian, I think.
Ben underscore Kushigian, yes.
And then I'm in Chasing Poker Greatness in the Slack, and several other Discords around. In the village. And I'm in Seattle, so just walk around Seattle and yell my name, and I'll come.
Beautiful. Yes, absolutely. And you can often see, like I mentioned in the intro, you can often see Ben talking about these concepts that we discussed today in a lot of detail, always great insight. And he's spending a lot of time thinking about those things if it's not already clear by the conversation we've been having today. And Peter, I don't know if you wanted to add anything else to the conversation before we.
No, I don't think I can. I like the way you guys finished that sort of that last question, and it more or less came around to the old stock poker answer. Well, it kind of depends.
Right.
That's exactly right. So Peter, where people can find you?
Oh, people can find me on Twitter, Duncan, at Peter Birmingham. There's a 4 instead of the M at the end, as I think all our listeners know at this stage. And you'll also find me knocking around the Slack group, chasingpokergreatness.com/greatness village. You'll find me there. And that's I just want to thank Ben for his time today, and a really, really interesting conversation and a very interesting topic. Thank you for your time.
Yeah, thank you both for having me on. It's an honor, and enjoy your content. So this is great.
Oh, thank you. We had a really good time. And Ben, again, if you ever have more thoughts, hopefully when you go back, you mentioned earlier that this is something that you're working on, and eventually you wanna reveal more information about it. When you're ready for all of this, we're here for you. You know, we can talk a little bit more, and let's put a temporary pause, and then we will reconvene.
Can't wait.
Excellent. Well, and thank you everybody for listening and tuning in, and we will see you all next Friday.
See you all next week.